Hey everyone, welcome back to Chemstrology, the podcast powered by OnlyTRAININGS, where industry experts and real-world problems meet practical solutions. I'm your host, Frank Harper, and today we're talking about something that keeps many engineers awake at night: metal failures. And to help us unpack this, I'm thrilled to have Jonathan with us, metallurgy science expert with over 15 years of industry experience, having worked with giants like Dow and BASF. Jonathan, welcome to the show.
Thanks, Frank. Always excited to talk about metal failures, though I promise we'll keep it less scary than it sounds.
Jonathan, let's start with the elephant in the room. With so much technology and data available today, why do we still see so many metal failures globally?
You know, Frank, it's a fair question, and honestly, it comes down to one thing. We underestimate how metals behave in the real world. People assume a metal part will behave consistently just because it passed initial tests. But in reality, processing variations, surface defects, residual stresses, environmental exposure, wrong material choice, all of these quietly accumulate until one day the part gives up.
So it's rarely a sudden failure.
Exactly. Failures almost always leave clues. Fatigue markings, discoloration, grain boundary features, corrosion morphology, but many professionals were never trained to read those clues, which is why failures keep repeating.
You've worked with Dow and BASF. What gaps do you see in how engineers diagnose failures?
Honestly, most engineers jump straight to the solution. Let's change the heat treatment. Let's switch to a stronger alloy. Let's increase coating thickness. But if you skip the root cause analysis, you end up treating symptoms, not the disease. And another thing, people rarely integrate microstructural evidence, fractography, and service history analysis together. They use one method and hope for the best.
So the problem isn't lack of tools, it's lack of a structured, practical diagnostic approach.
Exactly. That's what industries desperately need.
That brings us to the reason we invited you today. You're leading the upcoming online training, Metal Failure Analysis, Identification, and Remedies. What can participants expect?
I'm keeping it extremely practical and industry-oriented. We'll go through how to visually decode fatigue, creep, brittle fracture, hydrogen embrittlement, how microstructures reveal processing history, real failure case studies from automotive, machinery, and chemical plants, how to choose the right remedy, not just a temporary fix, a step-by-step diagnostic workflow you can literally use the next day. No heavy theory, no textbook-style explanation, just the things engineers actually use in real plants.
And that's exactly why the training demand is so high. People want hands-on, real-world guidance, not a lecture. Jonathan, if an engineer is listening right now and thinking, do I really need this session? What would you tell them?
I'd say this. If you've ever faced a failure and weren't fully sure why it happened, or if you've relied on guesswork, this training will change the way you look at metals forever. Everything becomes easier when you understand what the fracture surface is trying to tell you. That's the goal of this session.
Love it. And for everyone listening, the link to register is on onlytrainings.com. Just look for Metal Failure Analysis, Identification, and Remedies training. Seats are already filling up, so don't wait. Jonathan, thanks for joining us and sharing your expertise. My pleasure, Frank. Looking forward to meeting everyone in the session. All right, folks, that's it for today's episode of Chemstrology. Until next time, keep learning, keep solving real problems, and keep building better materials.